Hi fellas, welcome to this video on RMSE error curve. In this video, we are going to learn how does the error curve look like in a simple linear regression model. To illustrate this, we are going to pick the advertising dataset. Link to the dataset is available in the description of this video. So we have a scatter plot here which shows the relationship between TV spend and sales. So let's say sales is our target column and we are trying to predict sales using TV spends. Here we can see that as we increase the spend in TV, the sales is also increasing, which is the indication of positive linear relationship between TV and sales. Let's say we want to fit the best line that pass through the most of the data points and keeping the error to be very minimum. So let's say I start with slope 0 and I'm fixing my intercept to be around 5. Since most of the data points is starting here, I've just randomly taken 5 as the intercept. So assuming that intercept is 5 and slope is 0, this is our fitted line where we have a horizontal line which indicates that no matter how much you spend in TV, sales is going to be around 5. So in this case, if you compute the RMSE between the predicted values and the original values, the RMSE will be around 10.5. So for slope 0, that is for beta 1 0, RMSE is around 10.5. Let's say I fix my intercept as of now to be around 5 and increase the slope alone from 0.0 to 0.01. So I have a positive slope and the line is now close to the data points compared to the earlier flat line. Now you can see on the right hand side the error, that is RMSE, when the beta 1 value is 0.01 is close to 9. So it has come down from 10.5 to close to 9. So as I increase the slope further, you can see the RMSE is coming down. So let me increase it to 0.03 and then 0.04. So when my slope is around 0.06, I have a very minimal RMSE which is around 3. If I try to increase the slope further, my RMSE is again increasing. So if you try to increase the slope further, the line moves away from the scatter points and the RMSE value also will increase. So what is the optimal value of beta 1 then? So the optimal value of beta 1 is the value for which the RMSE is very low. This curve where we are changing different values of beta 1 and plotting the corresponding RMSE and fixing the value of beta 0 is a error curve, and the minimum value in this error curve will give you the optimal value of beta 1 for which the RMSE is very less, and this point in this error curve is called as global minimum. So the objective of a simple linear regression is to fit a best line for which the RMSE is very low, that is it reaches the global minimum in your error curve. So the corresponding beta 1 will be the optimal value. In this example, we have fixed beta 0, that is the intercept, to be 5. But in reality, you will also not know the optimal value of beta 0, in which case we have to find out that combination of beta 0 and beta 1 for which the error will be very minimum. So now we are going to alter the value of intercept as well. Earlier we kept it around 5. Now we are going to alter the value of intercept as well. So in which case there will be two parameters that we are going to vary. One is the slope of the line and another is the intercept of the line. And for the combination of slope and intercept, we will have different RMSE. So now our error curve will be a 3D curve. For every value of slope and intercept, you will have a corresponding RMSE. So slope values are available here, intercept values are available here, and RMSE is in the vertical axis. So now for the value of 0.6 as slope, the RMSE is somewhere here, in the error curve. Now let's try changing the value of intercept from 0.5 to 2. So you can see the dot is moving here. The ideal point will be somewhere here, which is the global minimum point, for which the RMSE is very low. So if you further increase the value of intercept, so we can see the error point will approach slowly close to global minimum, and we should ideally try changing the value of slope as well. So somewhere around 0.04 as slope and intercept as 8, the error is very close to, the RMSE is very close to the global minimum value. So from this we can say that our optimal value of slope and the intercept is somewhere close to 0.04 and 8. So here we are manually changing the value of slope and intercept and checking where is the optimal value of slope and intercept for which the error approaches close to global minimum. But in reality, when we implement linear regression model using scikit-learn or any other tool, algorithms like ordinary least squares or gradient descent will be used to automatically identify the global minimum point in your error curve, and the corresponding beta naught and beta 1 will be identified and given as the model coefficients. So the chart which shows the RMSE values for different combination of the model parameters, that is beta naught and beta 1 in this particular simple linear regression case, is actually called as the error curve. And the whole idea is to identify the global minimum in the error curve, and that particular corresponding slope and intercept will be the optimal values for the dataset that you have taken. Thank you.